Hey everyone, we're going to find the derivative of each trigonometric function using the chain rule. This is part 3. So the first thing I'm going to do is go ahead and start with the derivative. There's two ways to do this, so I'm going to do both ways. So the derivative of sine, so what I'm going to do is the product property, and I'm going to write sine of 2x. Now I have to take the derivative of cosine. So derivative of cosine is going to be negative sine of x, 2x, and then you have to also use your chain rule, and the derivative of 2x is just going to be 2. Then we have plus, you write your second piece, sine, that's cosine, sorry, cosine of 2x times derivative of sine. So that's going to be cosine of 2x times the derivative of your inner function, which is just 2. Now, cleaning this up, we're going to get, this is going to be negative 2 sine squared, because we have 2 of these, of 2x. And this one's going to be plus 2 cosine squared of 2x. And what I can do is rewrite this. Put the 2 cosine squared of 2x minus 2 sine squared of 2x. And if I factor out a 2, I get cosine squared of 2x minus sine squared of 2x. And if you're double angles, you know that this, if it was just an x, it would be cosine of 2x. But since we have a 2, it's going to be 4. So this is going to be cosine of 4x. Remember your identities. Cosine squared of x minus sine squared of x equals cosine of 2 theta, or 2x. Right? But since we have a 2 here, we just double that up, and that's going to be 4. Then we already had this 2 outside here. All right. Now another way to do this is using the your identities, double angles right up front. So we know that sine, 2 sine of x times cosine of x equals sine of 2x. So that's our double angles for sine. So what I can do is I can write this one, our h of x equals sine of 2x times cosine of 2x. So I can write this as 1/2 sine of 4x. Because if the 2 2's would make the 4, since I don't have a 2 right here like I have here, I have to take half of that. So when I expand this, I get back up to this. So anyway, when you have this, then we can take the derivative, and that's going to be the derivative of sine, which is cosine. And then you times it by your derivative of your inner function, which is 4. So that's going to be times 4. When you multiply these two together, you get 2. So both ways I had to use the double angle identities. Okay, we have one more. This one looks a little hard, but it's not that bad. So just has fractions. We're going to take the derivative. Remember your theta is like x. So treat it as a variable. So the derivative of secant is, well, we're just going to write secant first. We're doing the product property. The derivative of tan is going to be secant squared. And then you have to multiply it by using the chain rule, 1/2. Because the derivative of 1/2 of theta is 1/2. Then you're going to add your tan of 1/2 theta times the derivative of secant. And the derivative of secant is secant of 1/2 theta times tan of 1/2 theta. And cleaning all this up, you're going to get 1/2 secant of 1/2 theta times secant squared of 1/2 theta plus tan squared of 1/2 theta. And basically I just factored out the 1/2 secant. I factored out this with this. Okay. And that's all. Thank you and have a nice day. Bye-bye.